Today we're going to be talking about tractor types and uses. So the first successful gasoline-powered tractor was built in 1892, and it had all the basic elements of a modern tractor that we're going to be seeing in throughout this quarter. So some of those basic elements are it's self-propelled, so it drives itself with the use of an internal combustion engine. It can tow things with a drawbar, and it can also provide belt power, and we'll talk about what that means. But basically, you can tow things with the drawbar, or you can power stationary implements with belt power. So we'll talk about how modern tractors do that, but those are kind of the two main things that we use tractors for. It uses clutches to engage the drivetrain, to go forward and reverse. So you can start and stop, and you can also change direction. You can go forward, and it has reverse. It's steered by the operator. So with this machine, you kind of stood up there on the platform with that steering wheel and could drive it around. Before this, the really only tractors that were out there were these kind of huge steam-powered tractors, and if anybody's ever seen one of those, they're just massive machines. And really back then, that was only for huge operations and really, I would say, wealthy farmers, and that was, very small portion of the farms ever had anything like those. So anyway, this was kind of the first tractor that wasn't necessarily mass produced, but that a smaller farmer could use throughout their operation. So as we get into these are modern tractors, brand new today, and we'll talk about how we use them. So one of the most basic things that we're going to use the tractor for is to use the drawbar to tow things around. So the drawbar is used for towed implements, kind of like this picture down here in the bottom of the screen that's pulling a box scraper. We'll talk about what that is later. But, it's a fixed point on the tractor. It doesn't move up and down. It's like a hitch on a car or on a truck. It's just a fixed point. Some of the other things we'll talk about are different, but this is simply used to tow things around. It's not adjustable or anything like that, just to drag things. And this is kind of where it is, down low on the back of the tractor, kind of like in that red circle there. So the second thing is the next basic tractor attribute is the three-point hitch. So the three-point hitch is used in a similar fashion to the drawbar in that it is designed to tow implements. You're dragging things around, like the box scraper, or this picture down here in the bottom is a disc. You have to drag it through the soil. So we're towing things around, but it's different than the drawbar in that it is very adjustable. So not only is it used to tow implements, but you can lift and lower them as well. So that shows the discs being lifted. That picture on the bottom shows the disc lifted up off the ground. That's something you can do with the three-point. You can lift up the implement for when you don't want to use it, drive around, or set it back down. The drawbar hitch doesn't do anything. It is just towing things around. This not only tows things, but it lifts and lowers it as well. And then the third basic element of a tractor is the PTO, or the PTO stands for power takeoff. So it's used to power implements. This picture here shows a mower. So that's basically just a big mower, like a regular lawn mower. A lot of times you hear them called a field mower in the ag industry. But so it just has a big mower blade spinning around there, and that PTO is powering the mower blade. So you can see the mouse, you can see this black drive line right here that's hooking up to the back of the tractor at the PTO, and that drive shaft, when engaged, is spinning this mower underneath here that is cutting the grass. So you can use the PTO for all sorts of things. You can power implements like this that you drive around with or you tow around, or even stationary implements like, say, a water pump or a grain elevator, something that's fixed in place. You're not driving around with this water pump. You're parked the tractor and you're powering it. So in that sense, the tractor is really just a mobile engine, right? You can back this thing up, park it, and then you can power something. It doesn't have to be moving. You don't have to be driving it to be useful. So those three aspects of a tractor are really how we use them for pretty much any task. So we're kind of what they're designed around. Sure, there's specialty things, to use tractors for different operations and things like that. But when we think about actually using a tractor for work and whatever we're doing, whether it's farming or ranching or, I don't know, grounds maintenance, anything, we're using these three um, aspects of the tractor to perform work, to hook up different implements and power different things and that sort of thing. So our three most basic things that we'll be going over quite extensively in later presentations and in some of the labs. We'll be talking about how to hitch implements to the drawbar and the 3-point and the PTO and that sort of thing, and what we're actually using them for. So again, right, our drawbar, 3-point, and PTO are our basic elements of a tractor that make them universal and make them useful to us. So now, as we kind of go through this presentation, we're going to be talking a lot about some of the different tractors and being able to identify different things as we go through. So some of the first labs are going to be just identifying tractors and, and briefly talking about what some of their uses might be. So our first tractor is going to be a wheel tractor and what we're going to call standard. So the main thing with a standard tractor is we'll talk about the next different kind of version of this, but the track width is not adjustable. So when we look at this tractor, it might not be that obvious, or you might not think about this, but some tractors are adjustable width. So that means the tires can be spaced in or out on the machine. And we'll talk about why that's useful later. But the most basic type of a tractor, it's not adjustable. Right? It's the kind of cheapest version of it. It doesn't need this complicated mechanism to move the tires in and out or anything like that. So a lot of times you can do a couple things. Like sometimes you can flip the rims around on these, like, to get the tires to go in or out. But, you really only have a couple specific widths. It's not super adjustable. So it's not really meant for a specific operation or a specific crop. It's cheap and simple. It's the most basic version. If you don't need anything complicated, why pay for it? That'll kind of be something we talk about through a lot of these lectures is there are complicated machines out there, but if you don't need it for something specific or something like that, why pay for it? So this is kind of our most basic, cheap and simple tractor. And most of the tractors we see in class are going to be this type of a tractor, but we'll talk about some how some of them that are different and that sort of thing. So our next, right, the kind of opposite of standard tractor is what's called a row crop tractor. So row crop tractors have the main difference is you can adjust the width of the tires, so to fit down your rows. So this picture here on the left shows this tractor driving down, I think that's a bunch of corn rows, and the tractor tires fit exactly within the rows, right? You don't want to be driving down through your field and your tires on top of your crops because you're damaging your crops, right? So we want to be able to adjust the width to exactly what we want, and that's this tractor is driving down with this tire directly between these rows, so it's not damaging the crop. So row crop tractors have adjustable width so that the farmer can adjust it to their exact crop. Not necessarily that they adjust them all the time, but they can adjust them for their whatever they do every year to year, and they probably adjust them once and kind of leave it. A lot of times if you see, this is the back tire on a tractor and it has this shaft sticking out, so you can loosen the clamp that is clamping the rim to the shaft and you can slide this in or out, and that's what makes a row crop tractor a row crop tractor. So at least traditionally this is kind of, you saw this and you still see this on modern tractors as well. Nowadays throughout the locally here in the Central Coast, you see a lot of like strawberry beds and stuff like that, and these beds are made to be specific widths. So tractor manufacturers will sell tractors that are that specific width. So this is a row crop tractor, but it's set up a little bit different, and that's kind of set up for this basic, that's probably a 60-inch bed. That's kind of a standard. Maybe that, I don't know, there's a little bit wider ones. Maybe that one's a little bit wider, but 60 inches is a standard. So that tractor is kind of set up to be 60 inches wide, and it's really not adjustable. If you look, there's no axle shaft sticking out, but it's still a row crop tractor that's designed for that specific task. So still, wheel tractors, there are different types of row crop tractors even. There's what's called a row crop tricycle. So traditionally, this was pretty popular for a while, but I don't think they really do it anymore. You've probably seen tractors like this that have kind of a narrow front end, not necessarily a tricycle and then it has 3 tires, right? You can have 4 tires on it, but the front tires are super narrow. So again, you kind of circle back to this idea of a row crop machine, getting down the rows and not damaging your crop. So if we kind of come back to this slide right here, you can see this tractor driving down these rows. They have the back tires are in this row, and then your front tires, if it was narrow, would be in this one here in the middle. So a tricycle is kind of traditionally, that's kind of the setting that this would be designed for. So anyway, the rear track width is adjustable and the front end is not adjustable. It's narrow, so but it's intended to always fit down that in between the rows. These are not, I mean, I don't know if anybody's ever ridden a three-wheeler, like those off-highway vehicles, right? A three-wheeler, but they're really not the most stable configuration, and that's kind of why they're not produced much anymore. Is they're not the most safe, and they also are they ride really rough, right? For various reasons, but the front end is super bouncy. If you ever driven one of these things around, the front end tends to bounce a lot. Like I said, yeah, not the most common configuration in modern tractors. So row crop standard, similar again. I think this is even the same model tractor. Oh, sorry, as this one, but instead of having a narrow front end, it has a wide front end, similar to a normal tractor. But again, we have this adjustable rear track width, and now the front end is adjustable as well, right? You need to be able to, if you're going to have a wide front end and a row crop tractor, you're going to have to be able to adjust this width as well as the back to make it fit down the row crops. So standard tractors or standard width tractors are more stable than tricycles, and they ride a little bit smoother as well. So pretty much nowadays, a row crop tractor is a row crop standard. It's not necessarily, they don't really make tricycle tractors anymore, but there's still a lot of them out there. Okay, so that kind of gets us the kind of most basic attributes of a standard versus a row crop tractor. Now we're going to talk a little bit more about the different drivetrains that you guys are going to see in lab as well. So wheel tractors, again, we're still talking about those. We'll talk a little bit about crawlers as we go through, but wheel tractors and most of the machines you guys are going to see are going to be two-wheel drive tractors. So as you might have a feel for when you go buy a two-wheel drive or a four-wheel drive pickup, a two-wheel drive truck is far cheaper and than a four-wheel drive, right? They're less complicated. You don't have the powered front tires or anything like that. So a lot of times, two-wheel drive machines are going to be cheaper and less complicated. They're less to maintain as well. You don't have the added complexity of a four-wheel drive machine. And they're better suited for operations where traction isn't necessarily an issue. So a lot of different operations, you don't necessarily need four-wheel drive, so why pay the premium to have it? One example I threw in here is this is a hay baler, right? So he's towing around this implement, and it's making these round bales that you can see kind of in the back of the picture. So this operation, you're basically just towing around this thing kind of like a trailer, and then the PTO, the power takeoff, is powering this, and it is rolling up the bales, and then it wraps it in net, and most of the power of this machine, most of the power of this operation comes from the PTO, right, running this implement. It's just simply dragging it around. So really, traction is not an issue. And if you think about baling hay, you're not baling hay in the mud, right? You have to have dry hay to bale it. So the field is dry and firm. You're not doing this in the middle of the winter or something like that where it could be muddy or traction could be an issue, right? That's just not a setting where you're baling hay. So, you know, in this sense, if you buy this tractor and you're pretty much just going to run a baler with it, why buy a four-wheel drive tractor, right? It's more expensive. You don't need that. So you might as well just buy a two-wheel drive tractor to run your baler. So anyway, that's kind of what I'm alluding to with this. So two-wheel drive, less complicated. It's cheaper. You use it in operations where traction isn't necessarily an issue. And then we'll talk about this a little bit more as we go through, but this 47 to 61 drawbar efficiency means that if this tractor makes 100 engine horsepower, so the engine makes 100 horsepower, when you think about the drawbar towing something around, we could calculate how much horsepower the tractor makes simply towing something. And I'll show you guys how to do that calculation later. But with a two-wheel drive tractor, you really only get like 47 to 60%, 47 to 61% of that engine horsepower available at the drawbars. That's pretty low, but you know, even with other machines, we're not going to get that much higher. So if this makes 100 engine horsepower, we can only, you know, maybe we'll get 50 drawbar horsepower out of this piece of equipment or out of this tractor. So pretty low. But again, right, when we're thinking about towing around a baler, that doesn't really matter, right? We don't need that. We don't need all this drawbar horsepower to tow this thing around. It's pretty easy to just drag this thing around and run the PTO. So the next one is what we're going to call FWAD, or front wheel auxiliary drive. So you might think of this as four-wheel drive, but it's not. We'll talk about what real four-wheel drive is on the next slide. But front wheel auxiliary drive, a lot of tractors look like this. They have big tires on the back, and then they have small tires on the front. But they all the tires are powered, right? So it is kind of four-wheel drive when you're thinking about that. But really, this is front wheel auxiliary drive. The front tires are smaller than the real tires. Smaller than the rear tires is how we're going to designate this. So they're a little bit better than a two-wheel drive tractor. We get a little bit more drawbar efficiency, 55 to 65%. So again, imagine 100 engine horsepower. We're going to get 55 to 65 drawbar horsepower when we're towing things around. So a little bit better, but not like, you know, you're not getting double the traction of a two-wheel drive tractor or something like that. So that is a little bit better, but not quite that much. So really, you know, if you look at our last percentages, we're really only gaining like 5% drawbar efficiency when we make the step from two-wheel drive to front wheel auxiliary drive. So, you know, you're not really gaining that much anyhow. And this is a much more expensive machine to have to make it front wheel auxiliary drive. And then it does steer similar to a two-wheel drive. So this is kind of a similar looking tractor, right? The front tires steer similar to everybody's used to in a car. All right, so true four-wheel drive. Tractors that look like this is what we're going to call a true four-wheel drive machine. So when we look at the front tires, the front and the rear tires are the same size. So every tire is the same size. Those are these huge drive tires, right? These big old massive tires versus our front wheel auxiliary driver. We had smaller tires on the front as compared to bigger ones on the back. So it's pretty common on these. I said regular front axle steering, kind of like a normal tractor, or articulated steering. It's probably more common to see articulated steering. We'll talk about what that is later, but basically the front tires don't steer. The whole machine bends in the middle to get steering with this. So these are really used in situations when you have a super heavy drawbar load. You're pulling something with the drawbar around pretty much all the time. And this, again, our efficiency bumps up a little bit. We're 60 to 66% drawbar efficiency, so we got a little bit more. But again, right, we're not making huge gains with this. So, you know, these types of situations, you wouldn't buy this type of a tractor and run a hay baler like we talked about, right? A PTO implement. You're buying this because of its drawbar efficiency. This is a much more complicated, much more expensive machine than a two-wheel drive tractor. So we're buying this for this a little bit better drawbar efficiency. So really, you're going to use this for just towing around implements that use the drawbar specifically, not necessarily. They don't really. You wouldn't buy this to run the PTO too much. Maybe you do sometimes, but you know, for I don't know, 75% of its life is probably just towing around drawbar implements. All right, so this whole time we've been talking about wheel tractors. We are going to see crawlers in class, so we'll talk a little bit about these as well. So crawlers with steel tracks, there are some different types out there, but this next couple slides are going to be talking about crawlers. So traditionally, steel tracks are more common. These are, again, kind of like we're going from two-wheel drive to front-wheel auxiliary drive to four-wheel drive, then up to crawlers. We are gaining efficiency as we go. And really, you can kind of think about the contact area on the ground, right? Crawlers have a lot more contact area, right? We spread out the area that's touching the ground, so we get a little bit more traction doing that. So our efficiency goes up a little bit more. Um, so really, these are going to be used in operations where traction is an issue and you're towing really heavy drawbar loads. I wouldn't necessarily buy one of these machines and run the PTO. And a lot of these machines don't have a power takeoff on it. Some of them, more ag use ones do, but not necessarily steel track. So, you know, this tractor, he's towing around a disc, which is a really heavy draft load. And then, right, you see this bulldozer on the top. Um, so you can kind of think of dragging around implements as the same as pushing around, you know, a big mound of soil with the blade on the front. Same, you know, you're pushing instead of pulling, but same idea, right? You're pushing or pulling these huge loads, um, and you know, traction's an issue when you're doing that, right? You need to have the most traction you can, get the most horsepower to the ground you can. These types of machines. So a little bit more on crawlers. A lot of times in ag, you'll see rubber tracked machines. So this is similar to our steel tracked crawlers from before, so our steel track machines, but they're very common in ag now is to see these rubber tracked machines. And the main, one of the big things with this is you can drive this down the road and you're not going to just tear up the asphalt or concrete. With these steel tracked machines, I'll keep going the wrong way. With these steel track machines, as soon as you drive this on asphalt, it's just going to wreck the road. So you have to trailer this basically from field to field if you're going that way, or you got to trailer it wherever you're going to go. With these rubber track machines, you can actually drive them down the road and stuff like that, which a lot of farmers do. If you're not going that far from your field, it costs a lot of money to have somebody put this on a semi truck to drive it around. So if you can drive it, even though you can only go 25 miles an hour, but if you're going to drive it 10 miles, it's just cheaper just to drive it than to hire somebody to haul it there. So similar to steel tracks, but they don't tear up the asphalt. That's kind of the big thing. And very common in ag. Again, we still get the crawler, the greater efficiency than the four-wheel drive or the two-wheel drive tractors. And then another big thing that's a benefit in ag is we get very low soil compaction. So similar, kind of spreading out the footprint of this machine to get a little bit better traction. You're also spreading out the weight of it, so it's not packing the soil, which is beneficial for crops, right? If you pack the soil down, it's hard for the roots to get into the soil, and you know, and also the water and the air to get into the soil as well. So that can be bad for your crops. So spreading out soil compaction is better. And then there are some kind of adaptations out there. There are some specialty machines that that kind of look like a combination of what we've been talking about. So wheel tractors with tracks. This, you see a Quadra-Trac. There's a handful of these different machines out there. So Case IH makes a lot of these, or John Deere makes these as well. Basically, it looks like a big true four-wheel drive machine, but instead of having tires on each corner, they put tracks and call it a Quadra-Trac, right? Because there's 4 tracks. These things can be a little bit easier to drive around, and with any type of crawler, they are hard to, or they kind of tear up the ground when you turn. So making a Quadra-Trac or these kind of half-track types of machine, they're a little bit easier to turn without just tearing up the ground every time you want to turn it. But anyway, you still kind of get the benefits of low soil compaction and more traction, a little bit higher drawbar efficiency with these, but without tearing up the ground so much when you're turning. Back to wheel machines. So there's a little bit, some different types of machines. You saw in some of these pictures, you saw tractors with multiple tires on it. So you can have all sorts of different configurations and just in the tires out there as well. So single, double, and triple tires on these big machines. Generally, these are only on like the really big machines. And again, we're kind of trying to spread out the footprint where the contact area with the ground. We're trying to get more contact area to spread out so we get less soil compaction and more traction. Those are kind of the big, this is kind of what's going on, more contact area with the ground. And these are the big benefits why we do this. But you've seen the tractor machines out there, pretty common to see these machines with multiple tires on them. It's pretty new in the industry is to see tractors with just single tires, but they are like the newest tires are just huge single tires. So this machine up here, right? Yeah, it has really wide tires on it that are almost kind of as wide as two of these, and that's pretty common, or it's becoming common in ag now. Traditionally in this class I've had, or a couple times in this class I've had the John Deere dealership loan us a tractor to use so that we can, see some of the new modern equipment. And they usually let us borrow a machine with the massive single tires on it. So it's kind of fun to use. I think they're saying that this is, the front tires are 1 meter wide. So I guess that's a little bit more, close to 3 feet. And then the back tires are 1.5 meters wide. So they're huge. But again, we're spreading out the contact area with the ground, getting more traction and that sort of thing. The salesman at John Deere, which I don't know how much I believe him, but he was telling me that they were getting more traction with these giant single tires than with tracked machines. So I find that a little bit hard to believe, but it'd be interesting to see some actual traction kind of comparisons. But anyway, that is kind of the new thing. It's really only been out for a handful of years, not that long. So briefly, we'll talk a little bit about some of the steering things you guys will see in this lab. So, the most common front wheel steering, right? Just like you guys are used to driving your car, you turn the wheel and the front tires turn left or right. No different than really anything out there. So that's one thing that you guys most all the tractors you guys are going to drive are going to steer that way. You guys will get to use a forklift that is going to have rear wheel steering. So later on, towards the end of the quarter, we'll get to see how to run a forklift in kind of a specific an off-road forklift that you'd see on ag settings more, and then there may be one of the warehouse forklifts. But anyway, common on forklifts to have the back tires steer. We'll talk about why that is when we talk more about forklifts. But anyway, it's mostly because we have the majority of the weight, all right, the load that we're picking up is over the solid front axle that doesn't steer. So this is, built to be super strong, all right? A steering axle is a little bit lighter duty than a non-steering axle. So the back axle that's kind of lighter duty steers. The front axle where all the load is a solid axle that does not steer. So anyway, that's kind of one of the reasons. Another thing that you guys may see as we go through this is coordinated steering. This is super common on machines like this. This is called a reach lift. Anyway, the front and the rear tires steer. So kind of down here, there's all the different things you could potentially do. And a lot of these machines, you can change how you want it to steer based on what you're doing. So you can just have the front axle steering. You could make the front axle stay still and the rear axle steer. Or this is the main benefit right here, this number 3, is that if you want to turn to the left, you turn the front tires to the left and the back tires to the right. And you can take this really large, machine and make it turn a relatively tight circle. So you gotta have this big lumbering machine and it can still steer pretty sharp when you have coordinated steering. So that's kind of the main benefit A lot of times you see this on like these reach lifts that are on like construction sites where you might not have a lot of room, but you can still get this big machine to turn pretty sharp corners. All right, one more slide. Okay, articulated steering. So we briefly mentioned this on the large four-wheel drive tractors. This is really where you see most of this, is these big four-wheel drive tractors. And the axles don't steer at all. So the tires don't pivot kind of like a car does. None of that happens. The whole machine pivots about the center of the machine. So this is super common on really large, really heavy-duty machines. Like I kind of talked about with the forklifts, having this steering axle where the tires pivot is kind of a light duty axle. It's not the most robust. Um, so having the machine having just solid, big, straight axles that are very heavy duty, and then making the machine bend in the middle is a way to, get steering. You have to have steering, but have a very heavy duty machine. So a lot of times these machines, this shows the engine and the cab, everything up on the front of the machine. They do make these machines with kind of a different configuration with the cab on the back. Kind of depends on what you're doing, and we'll talk about that a little bit later. So these are kind of the different things we're going to be talking about as we go through the different labs and lectures as we go through this quarter. But from the different attributes that we talked about, the drawbar and 3-point and PTO, and then the different types of machines, all these different aspects will pop up as we go through this quarter.